Ready? Alright, hi, I'm Mr. Straight, and I'm going to take you guys through a crash course in the first part of algebra where we deal with equations, patterns, graphs, tables, and all those things that we're really familiar with algebra. So, to start us off, we're going to take a look at the first core learning goal, which deals with types of patterns. We have an arithmetic sequence, which has a constant rate of increase or decrease, also known as a slope. Its addition or subtraction of some number is used to create the sequence. All right, so if we take a look at this example here, we've got 4, 7, 10, 13, ... So this means that it increases or adds 3 to each number to get the next number. So again, arithmetic increases by a constant amount, or a slope. All right, geometric sequence. This is where we have an increase or decrease at an increasing or decreasing rate. There is not a constant term. So in this case, we cannot make a linear equation, or an equation that we deal with in Algebra 1, because we don't have a constant rate of increase, which is a slope that's necessary to make an equation. But we can figure out the next terms in the pattern. For example, 5, 8, 13, 20, 29, and 40 are our numbers. Well, if we take a look at the differences between each term, we have a plus 3, 5, 7, 9, and 11. So we notice that the differences are increasing by 2 every time. So if I was to try to find the next number in this sequence, I would just add 13 to 40. So that's the two ways that you want to find out whether you can determine whether you have an arithmetic or geometric sequence. And it's important to know whether or not you have a constant rate of increase or a rate that's going higher and higher at an increasing rate or decreasing rate. Okay, so let's try some questions. Alright, so this is what a typical question would look like for just a simple pattern. We've got people serving in the cafeteria telling us the time of the day and the total number of people that were served up until that point. So at 12 o'clock, 25, 12:10, 55, 12:20, 85, 12:30, 1:15. Question says the table below shows the total number of people served in the cafeteria. If the pattern continues, what will be the total number of people served by 1 o'clock? Well, the first thing we know that if this is increasing by 10 minutes, we need to go down every 10 minutes until we get to 1 o'clock. So then we'll take the table and we'll find out if it has a constant rate of increase or decrease and use that number to go down to 1 o'clock as well. So I notice from here, from 25 to 55, I have plus 30. From 55 to 85, plus 30 as well. And again, plus 30. So, at 12:40, 12:50, and 1 o'clock, I need to find my total number of people. So 115 plus 30 is 145. Plus another 30 is 175. And another 30 is 205. So we would circle C. 205. Here's an example of a geometric sequence. Looking at the... Alright, so our geometric sequence here. 0, 3, 8, 15, 24. If the pattern continues, what will be the 8th term? Alright, that's key. A lot of people just assume it says next. Make sure you know what term you're finding. Alright, so we see 5 terms. 1, 2, 3, 4, 5. We need to get to the 8th term. So we'll try to find the 6th and the 7th and the 8th so that we can get there. But first we need to identify the differences. From 0 to 3 we have plus 3. From 3 to 8 we have plus 5. 8 to 15 plus 7. And from 15 to 24 plus 9. So 24 plus 11 will give us the 6th term, which is 35. Alright, now to get to the 7th term, 3, 5, 7, 9, 11 plus 13. That gives us 48. Alright, 3, 5, 7, 9, 11, 13, 15 will give us our 8th term. So we have 63 as our 8th term. And that answer would be C, the invisible C. Alright, so again, geometric, we're still looking at differences between terms. But in this case, they're increasing at an increasing rate. All right, let's take a look at one. I broke down an ECR into chunks. There's no more ECRs and BCRs on this test. Yay! But we're still going to have tables, patterns, things to do with all this stuff. All right, so we see a table of carpet cleaner rental. Number of hours, 1 through 6, and a cost of 16, 22, 28, and 34. But we need to find the last two costs. Well, that's easy. We can take the differences. Plus 6, and plus 6. I think it's going to keep going by 6s. So, 34 plus 6 is 40. And 40 plus 6, last time we checked, is 46. So we just completed the pattern, and it's as easy as that. Now from the pattern, here's where we take off into equation land. Because with any constant rate of increase or decrease, remember I kept saying that was a slope. All right, that's really important. All right, so here's the table with the answers filled in for us. Our goal is to write an equation to represent the relationship between the cost of renting carpet cleaner and the number of hours that a carpet cleaner is rented. All right, so we have the cost as related to the number of hours that you have the carpet cleaner. So we know that this is increasing by 6 every time. Well, that is the exact definition of a slope. Constant rate of increase or decrease all right, that is a slope, and it's very, very important to understand that. So what that means to me is, as I rent the carpet cleaner for another hour or another hour or another hour, it's going to cost me $6 more. That's a slope, plain and simple. All right, so how that's important though, remember this little equation form? It's there in your minds, I know it is. It's got to be there, because everyone knows that. But we always forget what these are. So here we go. Slope is your m. So when we're filling this equation in, so far we have y equals 6x plus something. What's that b? Well, remember the y-intercept is your starting value, or the value, get that up there, it's the value of y when x equals 0. All right, so if you have 0 for x, that number that is y on the other column will give you your y-intercept. Well, if I know that I'm increasing by 6 here every time, and I notice that my number of hours is 1, I think I can just go this way, and I'll write in a 0 up here. And if I've been adding 6, well, to go backwards, it makes sense to subtract 6. So 16 take away 6 is 10. And that's my y-intercept. There's my equation. Y equals 6x plus 10. 6 because every time I rent the carpet cleaner for another hour, it gives up another $6. And if I didn't rent it for anything, all right, just to get the carpet cleaner from the store, is $10. And then it's $6 per hour after that. All right, so it's like that upfront charge and then a cost per whatever when you have it. Which reminds me, the word per, each, every, for, you see those words, we'll start to see them later. That indicates that you're going to have a slope. All right, so taking that equation, we've taken a look at how to make an equation from a table. We want to find those differences. If it's a constant difference, that's a slope. If you can find out what y is when x is 0, then you have your y-intercept and you're in good shape. I can do anything I want with this. I can find out a cost if I know the hours I'm going to rent. If I have a cost, I can find out how many hours I can have it for. All right, so that's important to have an equation. So here it is again. Now, I got some nice handy screenshots to show you how to do it on a calculator. Logistically, we can't get calculators out to everyone for this thing because there are quite a few of you and only one of me. So I will show you how it looks and then you can take it from there. So in the y equals, in the graph where you set up your equations, you can put this equation into y1. Right? If you press second graph, which you'll see later, we're going to use this, so that's why I don't have it here. All right, so I'll teach you how to do that more later. Second graph gets you to a table. If I scroll down, so the question